trying to figure out what to do with this TDD thing everybody's talking about, right? Out of curiosity, who's actually doing unit testing? Just raise your hands. I can actually see that. Oh, this is. I've actually did talk like there were 200 people and like 3 people raised their hand. Like, what is the rest of the people doing? So I'll be sharing all the pains, all the things I experienced in the last, I guess, 15 years, trying to practice test-driven development, and going to be sharing my experience with that. In case you're wondering, who am I? Well, I like to call myself a coding architect. That's because I like to be an architect, but also like to be coding with the teams, which is usually what I do. Mostly in .NET and C#. Well, C# is .NET, but obviously. And these days, you can't really focus only on .NET or C#. You also have to do a bit of front-end development. So I like to use React and Vue, and I love TypeScript. I've been doing professional software development for almost 30 years, not counting the 10 years that I spent on my Commodore 64, my Commodore Amiga. I guess I see some people that might even remember that time. Which means if you do the calculations, I'm probably somewhere in my 50s. Yes, guilty as charged. And I maintain a couple of open source projects. One of them you may know. Anybody has been using Fluent Assertions? I'm not going to ask whether you stopped using it, but no, I still love it. I still maintain it, but I also maintain a bunch of other projects, and I'm everywhere. If you really want to talk about me, but also talk to me, or share your experiences, I'm on Blue Sky, Twitter, Mastodon, and I'm an MVP. Don't know how I got that. Don't know how to say it, but anyway. Oh, and I work for a small company in the Netherlands called Aviva Solutions, which you probably don't care about. So, let's get to the video. What is this TDD thing about? And this is not a beginner session. I'm trying to be to share some of my ideas here. So, I like to take a bit more pragmatic approach to TDD. That's the thing. You know, some of the books, they probably, if you read about them, will tell you that the first thing you do is create a test, something like that. And then you start to iterate on the implementations. But the first thing, I completely disagree with that, in case you're wondering. Yes, because nobody in their sane mind is going to create a test without first thinking about responsibilities, about like what are the different bits and pieces that I need in my design. You may be doing that by the top of your head. Maybe you're using a whiteboard and discuss it with some of your colleagues. I sometimes use like a paper thing or something, or a digital whiteboard. But the thing is, when you build something new, you typically start to think about responsibilities. What is supposed to happen in which particular order? How I'm going to distribute these things? What design patterns do I need to use so that I can, you know, complete my bonus card? But this is the important thing. By the way, if you are fixing a bug, then the first thing I do is actually creating a test to reproduce that bug. But if building new things, and I love building new things, we all love building new things, actually, greenfield, this is what I do. And then maybe at some point I will start creating a test, maybe generate some stubs, you know, with your IDE. I'm a big fan of JetBrains Rider, who are not at the NDC to this week. I'll make sure that that test fails for the right reason, especially if I'm fixing a bug. I actually want to make sure that, that the error, the exception, or whatever happens, is the one that is supposed to happen. Maybe you recognize that. I've actually fixed bugs by doing this, creating tests, and then I remove the fix to make sure that that particular test that's supposed to reproduce it is still failing. And I've actually experienced that. I've been, you know, refactoring the code base so much that I was actually fixing the wrong thing, which you never happened, of course, right? No, of course not. No. Then I implement the real deal, and I make sure the test becomes green or whatever color you prefer. And then what? What happens after red, green? Anybody? No. Yes. No, that's the real beauty of TDD. I mean, it's called test-driven development, but it's really test-driven design. Because what will happen, and at least that happens with me when I practice this, is when I'm implementing a couple of those tests, I'm actually coming up with all these alternative scenarios. I'm starting to think like, oh, wait a second, what happens if I do this? Even worse, I've also discovered that by the time I'm at that point, I discovered that I had the responsibilities set up wrongly. I'm going back to the drawing board. That's also completely normal. That's actually the value of that. So I identified all these scenarios. Sometimes I just write them down in the code, use code comments and stuff like that. And then I keep repeating that. I'm a very conservative guy. I don't refactor before I actually know that there's a pattern. And then maybe I start refactoring. So I like the rule 3. Maybe you've heard about that. It's not like you need to drink 3 beers at every conference party, but it means that if I see a certain thing in code happening twice, I kind of assume it's a coincidence. If I see something 3 times, I'm starting to think, okay, this might be a pattern, but I really want to be sure that's the case. And only if I'm convinced it's a pattern, I start refactoring. In fact, sometimes I make it very ugly before I make it beautiful again, because I really want to make sure I'm not prematurely optimizing my code and applying all kinds of patterns. Like, has anybody read, like, anybody old enough to remember the white book, The Gang of Four, Design Patterns? Yeah, anybody actually had that book on their desk? Yeah, yeah. Me too, I'm proud of that. But design patterns are very useful to refactor your code base. They're not a goal in itself, by the way, which goes beyond the point. And then, you know, the whole cycle completes. And obviously, this is not like a waterfall approach. It's really not happening in that always in that order. It is really a creative process, but that's the value of it. It's a design thing. It really makes you think about the semantics of your code base, what the API will look like, how you're going to make it testable. I have to deal as a consultant with a lot of legacy code bases, and I really have seen and observed the pattern or the symptom that when something wasn't designed for testability, it's very complicated or very painful. Well, I would actually use the word painful, which best describes the feeling I have, is that to make it testable again, because people didn't think about it. You suddenly have to, I don't know, mock all kinds of generic types and complicated stuff, which I don't want to do. Anyway, so this is, this is how I practice test-driven development, in case you're wondering. So red, green, refactor, no. Design, start doing some testing, you know, iterate, learn from that. It's almost like a small agile project. So if you do this great, it's going to make you happy. You end up with like being able to test things in isolation. You're going to make your code like designed properly. You're not adding unnecessary abstractions, but you actually, you know, end up with something that's well maintainable or better maintainable. I mean, it's not a silver bullet, right? They don't exist, but it can actually do this. It gives you confidence, because ultimately what you care about when you need to modify people's code is that you feel confident that you didn't break anything, right? That's what really everything is about. Everything we do, all these conferences we visit, we try to maybe learn some new technology, but in the end, you want to also be able to change code without shooting yourself in the foot. And that's what TDD and all these tests that you build make it possible for you. They can also be used as documentation. I honestly believe that, like all the code, all the tests in, for example, my own open source projects are there not just to make sure that it didn't break anything, but also as examples, like if somebody asks, like, how can I use this thing in a particular case? I usually have a test case for that I just share a link on GitHub, and then you have documentation. I really believe that. Keeps you out of debugger hell, as Jeremy Miller once said. But if you do it wrong, and this is where all the negativity comes from, yeah, it's going to hurt. You know, you may have to rewrite tests whenever you start refactoring. If that happens, you probably did something wrong. I will talk about it a little bit more. It takes ages to run. You know, they're difficult to understand. You don't actually understand what that test is supposed to do. And even if you do understand what that test is doing, you may not understand what it was supposed to do. Also part of that. Maybe they're flaky. You know, you recognize that? You run a bunch of tests, and some of them become red. You know, and then you run the red ones again, and then some of them become green, and a couple of others become red. Well, that's something we know if you do UI testing. It's a pretty common thing, but it's painful, and you need to try to weed that out. And of course, you spend a lot of time in the debugger. Although I like using a debugger. I absolutely love it, I think. But it's going to cost a lot of money in my clients if I do that. So one of the most difficult things to get right when you do test-driven development, or even unit testing in general, is finding the right scope. Because a lot of the books, they will tell you that you should test every method, every class independently. Like the unit is basically the smallest thing possible that's in your code base. This is a gross misunderstanding of the books, or the writers misunderstood what they were writing about. I'm a pretty opinionated person, I'm Dutch, I have that. But I like to take this in a different approach. So I have an example. Like, look at this little example here. This happens to be an extension method in this library that I've built, Fluent Assertions, that allowed you to compare two object graphs in a unit test. And it does a recursive analysis, and it understands like how to compare dictionaries, how to compare strings and stuff like that, which means there's a lot of logic behind that. When I created this thing 15 years ago, 15, sorry, not 50, 15 years ago, there was just one class, right? So imagine that I would actually have directly tested that class. Everything would be fine. Now try to think about the example of this. Look at this diagram. This is UML. If you're old enough, you might recognize this, this way of depicting software. Nobody draws diagrams anymore. And this is just a subset of all the code that's behind that single extension method. Now imagine that if I followed the book by the letter, I would probably have created tests for every class in this picture, and every time I decided to refactor my code base, apply a new design pattern to make it better to understand and also make it easier to maintain, I would have to rewrite all those tests. That would be madness, right? You agree? That would be madness, please? Yes? Yeah? Okay, some people are like, okay, I'm not convinced yet. Well, I will tell you, it would be very painful if I had to do that. In those 15 years, I've never had to rewrite a test because I never actually tested at such a small scale. So I've actually learned that testing at a little bit of a higher scope or bigger scope is beneficial and is one of the secret ingredients that I feel made me successful in practicing test-driven development. Of course, you can debate whether I'm successful. I don't know, maybe ask my clients, but at least I get paid. So this actually works. And I've seen a lot of code bases the last couple of years where people were testing at a really small scale, and that sucked. Oh, sorry, it's recorded. That was suboptimal. Looking for words. Okay, so I'm actually testing all of this as one unit. Now, to give you a bit more, like a more painful or more realistic example, I'm going to show you something else from a recent project. And I hope you can follow me, because it's not going to be trivial, and I like non-trivial examples because they are real. I have this user story. Given a collective agreement, which could be like a pension or insurance beneficial plan for your employers, is assigned to an organization, then we need to make sure that if that agreement, agreement is inheritable, that we also apply this to all the subsidiaries of that organization. Pretty simple example, right? Hope you can follow me. The architecture that was given to me consists of this. We had this dynamic CRM system, pretty old, and this logic was too complicated to put in CRM. So instead of that, we actually tried to put this in an Azure function. And we also needed to get some information from some existing backend services. So what happens is at some point, somebody uses the CRM system through the user interface, creates a new collective agreement, assigns it to for example, the mother organization. That triggers an event through Azure Service Bus, which ends up in the function, and the function is going to talk with the backend service to fetch all the subsidiaries of that organization. Bear with me. Now, when I've done that, I'm going to iterate through all these subsidiaries and tell the CRM system I'm also going to assign that collective agreement to the subsidiary. Sounds like a pretty simple thing, like a simple loop or something like that. Now, let's go into the details. This is how a lot of developers build this kind of stuff. You know, the box is enlarged and you see a lot of different bits and pieces. I was actually thinking when the developer explained me the scenario, that's a simple for each loop with a couple of HTTP calls. But this person was thinking about, no, we need the mediators and we need handlers and command objects. And we need repositories, and we need abstract factory. We need validators to verify all the commands and queries. We need response objects, and we need automapper, and we basically need all the things that are currently not free anymore. Unfortunately, yeah, this is this is a real example, by the way. It's quite funny. And then I thought, okay, that's a lot of bits and pieces. Is that really necessary? Well, they were following a standard architecture called clean architecture, even though this little thing was just passing data back and forth. Not the purpose of this talk, but I've seen it a lot, like applying architecture patterns and design patterns that were not necessary. So my question was, how are we going to test that? Well, since these people have actually read the TDD books, they said we create tests for everything. So we have tons of little unit tests. Every element is covered. And at the end, everything is green. We have a very high test coverage, but we don't have a clue whether it's actually going to work in production because we're not actually testing the interaction with the backend service and the CRM. Because everything, and I didn't even draw all the interfaces. If you're in the .NET space, just checking like who's in the .NET space here? Okay, half of the people. In the .NET space, there's a thing that's very popular, is take every class and slap an interface on top of it with the same name, and then we put an I in front of it. Because we can do dependency injection, as if we need that for dependency injection, but okay, apparently somebody thought it was a good idea. Where was I? Oh yeah, so everything is tested, unit tested, but nothing works, even though everything is green. I don't like that, and by the way, I've made that mistake myself. I worked on a project which I designed because I was the architect, and we had like 25,000 unit tests. So everything was covered, and every time we decided like, okay, we need to refactor this, because there's again a new requirement from this annoying product owner, and I had to rewrite the tests. I don't like this idea. So what I do is a little bit of a simpler approach. I still have a couple of boxes, because at least my code became too bloated. I want to keep it simple. And I actually create tests at this scope. So what I'm doing here is saying that, you know what? All these internal details, for me, are implementation details. I don't want to test implementation details. You know, the whole purpose of this red pinkish box here is to be kind of a pass-through mechanism between CRM, a backend system, and back to CRM. Then I actually want to test that behavior. I want to see the messages that are passed back and forth, and I want to do that in a real test. I'm not saying that in my test I'm actually going to interact with the backend services, but I want to see the messages. Now, the question now is, what is this test going to look like? Well, I brought that code with me, and I'm going to demonstrate a little bit what it looks like and show you some of the things that I try to follow. That must be readable, yes. So the first thing you see is the name. An inheritable collective agreement propagates to all subsidiaries. Functionally, a functional name. I hate these, or maybe you've seen that, class name, underscore, method name, underscore, and then a tiny piece of text to describe what this test is about. No, I'm trying to explain what this test is supposed to do. What am I trying to accomplish here? Whether it's a method, I don't care, but I always try to keep it functional. In the past, I used the when something happens, it should do something else. I stopped doing it because it was too verbose. I like, you know, concise and functional. So I use a more fact-based. I got it from some article, and I'm also using my projects. Now let me see what's happening. And don't be, oh yeah, in case you're wondering, let's see. It doesn't even fit. It's a pretty big test. Pretty big. And you would say like, oh my God, that's way too big. Back to diff, and I'll show you what happens. So, as I really want to simulate the interaction with the backend system, I'm going to have, I use a library to mock HTTP calls. I'm actually saying that if there's a request on localhost on the path FMV working scope with some kind of ID, I want you to return JSON, and it is deserialized from this. This looks ugly, but my point is that for this particular test case, and I'm not saying I apply it everywhere, I thought it was important to show what is the actual thing that goes over the wire. And yes, I do trust the JSON serializer, so I'm not showing JSON. I actually use a .NET anonymous class, and I trust the JSON serializer to provide the right JSON there. Sometimes I actually include the JSON itself. If I have doubts, or if the design includes that, but what's important here is, if I think something is important for a particular test, I'm going to show that. Not in every test case, but at least in the first one. So in this case, I'm expecting this call, and I'm going to give some data back, which I know is also happening in production. I did some tracing. Then I'm saying, okay, the next thing what we're going to do is we're going to be calling this backend service a surface to find all the subsidiaries of a particular organization, all the way in the hierarchy. And this is what the URL is. It's an OData query. No, it's an HTTP API. Children/account ID, which is the organization ID, with a particular query part. And it returns, again, a JSON in an ugly structure, but it's a given. It's an existing API, which you have to support. And again, I make sure that if this happens, the right data comes back. The next thing is I'm going to collect, because I'm expecting, if you go back to the picture, I'm expecting, like this was the call we just made. Now I'm expecting at some point that we call back, we actually tell the CRM to create a couple of entries in the system. And I want to verify that. And you see lots of noisy code, for path, without a query, and then I'm deserializing what comes back to a dictionary, and at some point I'm collecting that as the posted body, which is a list of dictionaries. So I'm basically collecting all the data. Okay. Oh yeah, and it should return no content, because I figured out that that is the way it works. Then I need to create some kind of mock HTTP client, which is a .NET object to interact with your backend or with HTTP endpoints. I create a mock of that. And then I have to do even more mocks. Apparently, I need, for this handler, because this is the thing that I'm actually testing, I need some dependencies, so I'm all going to set that up here. And then I'm sending a service bus message, and if you lost track of what I'm doing, don't worry, that's not the point. The point is that I'm doing a lot of stuff. And this is where the Azure function is executed. Actually, and this is interesting, I'm calling execute on a class. Ideally, I would want to be able to run some kind of Azure Service Bus simulator in my test so I can simulate that, what really happens in production. I can't do that easily without, introducing Docker in my whole test suite. So for now, I accept the fact that I have to directly call a method. And then I'm verifying using this same B equivalent from Fluent Assertions that what comes back should be two bodies, which sounds really weird. There should have been two requests, two post requests, with the specific elements here, which I'm trying to compare. And this should actually, if it fails because of this B equivalent to, I get the right information back. It's a lot, right? It doesn't sound like a unit test. Really? Who thinks it's not a unit test anymore? Don't be afraid. I'm not going to do anything. Now, the funny thing is I don't care. It's not like I don't care about your opinion. I don't care whether it's an integration or unit test. I've actually consciously, in this particular problem, decided that given the functionality in this red box that I just showed you, that whole thing is implementation detail, and I want to really see the interaction. Sometimes, and that's completely acceptable, I also test at a smaller scale. Completely okay. You don't need to, if I learned one thing after 29 years of professional software development, is you shouldn't be dogmatic. Which means basically that I tell what people should be doing in my teams and they follow what I want. No, it's not the case. So this is, again, a case by case. And this is what makes TDD sometimes so hard. Every different problem requires a slightly different solution, which can be complicated for, I would say, junior developers that are still looking for, guardrails. But I really consciously think about that, because in this particular test, I find it important that I can see the cause and effect of my test. And actually, I don't know if you do that, but when I review somebody else's pull request, I usually start with the tests. I like the test. Oh, well, I don't like the test, but I think the test should tell me something about the behavior. It gives me an understanding about the internal architecture, the internal boundary. It also gives me clarity of the semantics. What kind of behavior am I going to expect? And quite often when I do that, I also identify like, okay, wait a second, but did the developer actually think about the alternative scenarios that popped up in my mind while I was reviewing the tests? So I literally start with the test. Well, as an example, we can make it a little bit simpler, not too much. So I have another version, which is the refactored version, and check out. And you will notice a couple of things. What do you notice? maybe something in the name at the top here. So actually what I do, almost all my projects, I postfix my test classes and my test projects with the word specs. It doesn't do anything technically. It is just a reminder to everybody who's working on my code base or on the code base I work with, like what you're really doing here is trying to specify behavior. They're not just tests, they're documentation, their behavior, that's what I do. It's just a tiny thing. This also feels maybe a bit awkward. I'm putting documentation on this test. Like, why? Because this was not a trivial one. I wanted to emphasize for the people that come after me, what is the goal of this test? Yes, the title should be clear enough, but you know, if it helps the next person, I'm not afraid to use code comments. You know, I know there's people that hate it and would say, like, if you need code comments, your code is crap. I would say bullshit. It is not. I mean, I'm not technically explaining what happens. I'm explaining what is supposed to happen from a functional standpoint. And if I have to really, if I decide to create tests that are a bit bigger, then that's what I do. It's perfectly fine. Well, you see the range thing. You've probably seen that. Range act assert to emphasize that. What else? Well, nothing much. This is still the same. This is also the same. This is all the same. This one is simpler. The whole collection of the bodies with all the serialization and dictionaries. I tend to then create methods or helper methods or extension methods, which is something that every developer in the .NET space has done in their career. I actually create helper methods to make that code easier to understand. I still keep all these details that you may feel like as awkward. I keep them because they're still important. So what I do is everything that is important for a particular test case, I keep it in. I want you to see that. Everything that I think is not important, I try to remove by applying certain practices or certain patterns, like extension methods. But also here, for example, I have a collective agreement assigned to organization handler builder. And this builder is nothing more than is called a test data builder, is a way to fluently build all kinds of objects. In this case, it's the subject in a test, to hide the things which are not important. Maybe you remember from the last one, there was a lot of mocking. I removed that because it's not important for this particular test. I put that in the builder. So if I go to the implementation, it's really not that special, but you see all the noise here. It's still there, but it's not important for that test case, so remove it. And then I can just say new builder using HTTP client. And for the rest, yeah, it's mostly the same. I didn't change anything. Now, this is the first one. And it's completely normal or completely logical that if you have to create a lot of these different tests, to start encapsulating all these messages into helper class themselves. That's what a test data builder or object model is a great way of solving that. And I do that. I've seen teams that actually build their own almost domain-specific language. It's a term from 20 years ago, DSLs, basically in your programming language, to make those tests almost functionally readable. I didn't do that because I didn't go that far. We don't need it yet. And that is something I also learned. Anybody heard about dry, which is not drinking tonight at the party? Don't repeat yourself is a very popular practice, right? We all practice that to make our code easier. I've learned that applying dry can actually lead to coupling. So I'm very careful not to create too much coupling in my code base. And that sometimes means that I just duplicate code on purpose, instead of introducing generic projects like .infrastructure or helpers or something like that. So I'm really careful to introduce all these refactorings, unless I need that because the next test cases are simpler to maintain. And that's an important thing. I try to be very conservative when refactoring. Like the first implementation of the actual implementation was I basically coded out the whole thing. It was a 200 line method, this Azure function, completely unmaintainable, but I first want to see it work, and then I was going to see, okay, how I'm going to refactor this and what patterns can I use to make it easier to understand. And because I created this ugly long tests, that covers the whole thing end to end in memory, by the way, there's no network connection here. Because I did that, I could easily refactor the code without having to rewrite the test. Now, I'm not saying you should do this blindly everywhere because it's going to hurt as well. But for some cases, yeah, I would recommend, and that's my advice, if there's one thing you remember, is that try to test a little bit bigger. That's really important. What else? Yeah, well, I mean, this one is, I can't make it simpler. There's just a lot going on. And this is on GitHub, so I can actually show you can check it out later on. There's nothing more to, but by the way, every time I look at my own tests, the existing test code, I'm always wondering, like, can I make this simpler? Is there an element in my test that I can remove to make it easier to understand? Because for me, tests, unit tests, automated tests, are first-class citizens of my code base. They are important. They're at least as important as the rest of my code, which managers don't like. Like, wait a second, you have 50% of your code base is tests? Really? How is that possible? Did you waste just 50% of the time I invested in your teams on tests? I said, yes, I did. Yes, but you will be happy because, you know, I really hate this situation. Again, for me, it's like driving without seatbelt. I don't know if it's a common thing in Norway, but I hate that. It feels like insecure. I want that confidence. I need those tests, or specs in my case, to give me the confidence that I know what's happening. And that is really important. You will earn that back easily, because that's one of the negative side effects, or the arguments against TDD, is that people are afraid, like, or the managers mostly, because they don't understand what's going on, they have no clue in general, that those tests actually are going to save us. Not just from a quality perspective, but they're also going to make it easier to, you know, make changes without breaking things. But find the right scope. Because if you have to rewrite those tests every time a new requirement comes in, you know you did something wrong. And it's not always trivial how to do that. But just keep in mind, try to understand your internal boundaries and then make it bigger. So what did I do? A couple of things. Yeah, I review the test first. I show the cause and effect. I make sure that I focus on the important things and hide what's not. Oh, the thing to sync the folder structure. You actually didn't see that. I like to also keep that in sync. So in this case, this is the functionality, working scopes. I don't know if this is a proper domain term, but that's what they used. This is where all the actual code is. And then in the test project, which happens to be specs as well, I use the same structure. So I keep them aligned. Because in general, I also like to organize all my code in functional folders. I hate folders like repositories and entities and views and requests and DTOs, because it doesn't actually help me understand the internal boundaries. I want to understand which request belongs to which repository. How are they all fit together? And that means always using functional folders. And then I do the same thing on the test side as well. What else? Short names and clear and focused assertions. What does that mean? Well, I already showed you that earlier. Is this thing here at the bottom, is that I care about those particular properties. By the way, this is interesting. If the data that comes back from this body, or that's in this body, if there's additional fields, this test will not fail, because I don't care about these additional fields. I care about the things I'm expecting. That is the effect of this should be equivalent to, and why I created this library 15 years ago, to try to emphasize the parts which are important for this test. The other thing is, maybe it is interesting, like, you may be asking, like, okay, so this orange box is also going to be sending this post message, right? It's building a post request. Are you not using some kind of, I don't know, class, .NET class or record or something to build this structure that produces this JSON? Yes, of course I do. I'm not writing JSON myself. It's 2025. Then why are you not using that same class in your test? Because then your test becomes much easier to understand, right? Yes, I could have done that, but my point again is that the interaction between my Azure function, in this case CRM, and this backend service is a contract. I want my test to fail if something changes, because if you don't, what will happen is you'll be rewriting maybe you rename a property on this class, often called data transfer object, and when you do that, then your test will succeed, even though you've broken a contract. You didn't even know that. Okay, sorry about that. So I try to be very specific, and I don't actually reuse code from production. I use these dictionaries, or in .NET I use C#, I use anonymous types, to really, again, emphasizing this test is really verifying something important. All right. Yeah, this is obvious. That's not it, because you thought maybe I'm done. No, I'm not. I have a bunch more. Coverage. Has anybody in that company have a bunch of managers creating these dashboards showing your code coverage with, green and, these things? Maybe you're also using Sonar Cloud or Sonar Cube. They're very notorious, yeah. And then your manager comes to your team, or if you're a tech lead, hey, guys, this month your code coverage dropped. You're now only at 93%. Last month we had 95%. You need to fix that. Well, I call that BS, because it's not actually a goal. Code coverage is very useful. It helps you understand where you've missed something, and obviously if you practice test-driven development, it's very easy to reach a very high code coverage. And again, it will make your manager happy, but never use it as a means to compare teams. Because obviously you can use AI tools these days to generate tests. But are these tests really useful? Are they going to actually help you understand the behavior? Because this is one of the discussion. I should have put a slide on it because there's no AI in my talk. And apparently that's a thing these days. I use AI all the time, every day. I use Copilot, I use JetBrains AI assistant, I use ChatGPT. I sometimes even use them to generate some tests, because sometimes it's really that smart and it will generate the right ones. But I never treat them as something that I will blindly accept. It's just to remove some of the cumbersome things, but every test should still explain what it's supposed to do. Now I lost track of my talk. Oh yeah, coverage. So coverage is just a way to identify where the gaps, where the black spots in your code base. Like if I go to a client and they have an existing code base and they have 60% coverage, I frown upon that. There's room for improvement, and they can hire me and I will help them to increase that coverage. If it's 80%, I would say, okay, this is great. They've done their job. However, you can reach 95% coverage without really testing anything. I just showed you this picture with all these hand-drawn circles where every method, every class was tested, but never the total thing. So even though this dashboard will tell you, hey, cool, you guys have been doing great, great team, but it didn't actually do anything. You didn't accomplish something. So you have to be careful. But again, it can help. This is in Rider showing you where it happens. It is useful. And this is, I think, from Sonar Cloud. Yeah. Gray box testing is another discussion. Should I actually academically prove that every combination from parameters is going to give you the right result? The books will tell you to do that. I don't think so. By the way, this is an example from my own open source project. So I'm actually doing this at one particular place. But this class was only meant to produce a toString implementation of different values. That's why I'm using this parameterized test. But this is not something I do easily. I'm very conservative in that. Well, maybe conservative is the wrong word. I'm afraid, and developers have a tendency of overusing those features, because they like to create as little test as possible and create as much coverage as possible. That's not the goal. Again, the goal is not coverage. So I like to take if you take a black box testing approach, you would be scientifically proving every parameter works expected. If you would do white boxing, you would making assumptions, or you would actually look at the code and make all kinds of shortcuts. I'm trying to find some kind of balance in between, if that makes sense. Now, the other thing is that unit testing is not just the only kind of testing you should be doing. And I've seen teams that either only did unit testing or only did other kinds of testing. No, they're all complementary. Unit test is what I just showed you. Whether your unit is as big as in my example or a lot smaller is not really the point. But you have different layers. You have unit test, that's the big chunk. That's why it's a pyramid. Then you have a layer of integration or maybe component tests. Again, I don't have a clear definition of what integration means. Could be a test that actually goes into the network. Could also mean it's just a combination of things. I'm very in favor of HTTP tests, like in .NET. It's very easy to build like tests that actually interact with an HTTP endpoint without going to the network. So if you're in the .NET space, you probably know controllers and that kind of stuff. You're not supposed to call the controller directly. You're supposed to send HTTP requests, because that is the actual contract you should be using. And that's also, again, it's a smaller section, because you probably know, yeah, how bigger the scope, how more complicated test is. Then we have the browser testing, you know, the ones that are always flaky. Anybody who has browser tests that are not flaky? Never, ever? See, no, yeah. And if they're flaky, what do? We just run them again, right? That's how we do it. No, it didn't fail. Look, it's green, you know? Doesn't work like that, but unfortunately. And then at the top, we have exploratory testing. What is that? Well, in my world, and I wonder what has that to do with TDD? Yes, it's about testability. The person that used to be called a tester, I like to call them quality assurance engineer. Those are the people that will be part of my team that will make the developers aware of the fact that we have to make everything testable. They will be part of your refinement meetings when you break down your user stories, your product backlog items, and ask very annoying questions like, how are we going to make this testable? You know? Oh, the performance has to be fast. How fast? Can we quantify? How are we going to measure that? That is the value of a quality assurance engineer. They will bring in this mindset and make sure we design things in a testable fashion. That's the value of that. Well, that person has another very useful skill, which I don't have and most developers don't have. They like to break your code base. They love finding bugs. It's like if they actually manage to kill your system, it's the best thing that can happen in a day. My best day if I can delete other people's code, but they will be very happy if they break something. And that is the value. They really try to use all the knowledge they have to break the system and potentially identify additional test cases you missed. And that's valuable. Why it's a pyramid? Well, you've probably seen that. You know, this is automated, this is manual. The higher you go in this pyramid, it's going to be slower and more flaky. It's not really rocket science, you know that. And the lower you go, the easier these tests are to understand, less debugging time. So you need all of them, not just one, but all of them. Fixture classes, I don't know if you know what it is. It's these reusable classes that you can use across all your test cases. It's a great idea. It's to be able to reuse code or state across a couple of test cases. It's not a bad thing per se, but the problem is people misuse them. They become like, you know, garbage collectors of all kinds of code that can be potentially reused, and I don't like that. It's the same reason why I'm a big proponent of object-oriented programming, even though it's 50 years old. But the inheritance part of that, people misuse that. Simply because they're not aware they're misusing it. They're putting all kinds of logic in there. So I'm very, very suspicious when I see fixture classes. And quite often they're big. And why is that an issue? Because again, every test, I want to be able to understand what's going on. It needs to have a reasonably clear cause and effect, clear assertions, well named, everything I showed you before. And those don't really help with that. Mocking, it's not a bad thing per se. I've heard there's actually camps, people that say mocking is always bad. I disagree. Mocking is something useful. Every tool, every practice that we have has advantages, right? And if you understand when to use them and when not to use them. So let's say I have this architecture, which is a bunch of functional slices in this case. I actually use mocking between those slices because I probably have these functional slices. I want to be able to test them in a decoupled fashion. I have interface in between, and that's where I use mocking. Maybe same here, maybe at this level on the left side, if you can see that. But inside, I don't use mocking. I use concrete classes. I try to test at a bigger scope, and as soon as you start doing that, you need less mocking or faking or stubbing. I never remember the exact details, and I don't care. I'm pragmatic. Then this one. What if your code is actually using a database? I would say it's okay. If it's a database that you can run as in a test container, like SQL Server, Postgres, RavenDB, you don't even need a container. It has built-in in-memory support. That's perfectly okay. I've actually seen code bases like a library or class. It was called, I think it was called like Database Manager. I guess you can kind of imagine what that thing is supposed to do, right? manage the database. So I would expect that class to contain code that will interact with the database, right? That's what you expect with that name. Managers is typically not the best name, but in this case, that's exactly what it did, manage the database. The developer decided that, yeah, but the database, I don't really want to test that because it's ugly. And somebody in the past said, isolate the ugly stuff. So what they did, they created all kinds of abstractions. I think it was called iSQL adapter and iSQL adapter factory, which is an example of the abstract factory pattern. And their unit tests, what they were doing is this database manager had a dependency on this adapter. Don't mind if you don't remember all of this in details later on. But the point was, their code was hiding the database. It wasn't even doing anything. It was just calling methods on the manager and verifying that the mocked abstraction of the database was being called. It didn't do anything useful. And now, these days, we can just use SQL Server in a container. We'll start in milliseconds. And that's totally okay. You don't have to do it with every test case, but the code that actually deals with the database, perfectly okay. Yes, there are abstractions like ORMs, anti-framework, and Hibernate, Java space, Hibernate, where it came from, that kind of abstract how database works, but in reality, they're leaky abstractions. I don't know if you've worked with, if you work with Oracle, your column names are very short, case sensitive to a certain extent. If you use Postgres, by default, text string comparisons are case sensitive. And you need to go through hoops to make that possible. Maybe it's fixed, but when I used it, SQL Server by default does make it case sensitive because you can change the collation. So all these abstractions are very leaky. In the .NET space, we love to use link. Well, some link statements cannot be executed by the database. And you only discover that when in production, I hope not, because you've created automated tests that use a real database. So do that. For example, using test containers for .NET. What else? Don't give people the opportunity to not run the tests. Who's using a CI pipeline? Azure DevOps, GitHub Actions, TeamCity, whatever, that's good. That should help you with that. They give you feedback that whatever was committed to that pull request isn't broken. And ideally, you also run all these tests on a pull request. That's not always possible, especially with legacy databases. But don't give that excuse. Also allow them to run them locally. Oh, the order of the pictures is wrong here. I use a lot of things like, for example, Nuke, which has nothing to do with what you think it is. It's actually a library to build deployment pipelines in C# that you can run locally, so that you have just one build script, build.ps1 or something, you can run to compile and run and all the tests on your local development machine before you push changes to your pipeline. I hate YAML, and I really hate Azure Pipelines YAML, because YAML is something you cannot execute locally. It's also difficult to maintain. Make sure you make things available for the developers to run the tests locally, ideally in their IDE themselves. And don't accept flakiness. If any test starts to become flaky, I once did that. I introduced a rule. If we see that any test is flaky, everybody drops their work. There's no other priority in the teams other than figuring out why is it flaky, and can we fix that? And then, of course, the question is, yeah, but it isn't flaky, so how do you know? Well, I just run it again, and now it's green. No, but then it's flaky, right? Yes, but I don't know why it is, because I cannot reproduce it anymore. Everybody drops everything from the hand, because if you don't, people will just ignore it. And then the amount of flakiness will just increase. It's getting worse. I've experienced this many times. Not necessarily had to do something with TDD, but the thing is, it is a really important aspect. In .NET, you have something called a blame hand timeout. And if you use TeamCity, for example, which is very nice, I'm a big JetBrains fan, unfortunately. If a test fails and it becomes flaky, you can actually assign the failing test to a developer and mark it as muted, so the rest of the build will continue to run, and it's clear for everybody in the team who's actually investigating it. Because maybe you recognize that, the build fails, and then nothing happens. Everybody is looking at each other like, okay, and now we're working from home, so nobody even knows, like, who's fixing this? I put a message on Slack, the build failed, who's fixing this? No response. This is not acceptable. or somebody is actually investigating it because they feel responsible, but it's not very visible. That's important. It's a common problem when you have like lots of test cases and also different layers of tests. So don't accept that. If you're in the .NET space, there's a nice library. I don't know exactly who created it. It's called .NET Retest. And what it will do is whenever a unit test fails, it will try to rerun it a couple of times. And if it then succeeds, it will be marked as flaky, which is a nice add-on if you don't have like an expensive build system like TeamCity. I used it a lot. It's very useful. I didn't even know it existed. Oh, and what if you have this huge code base that doesn't have any tests? What do? You run array. You find some other job, right? Actually, I enjoy that. And there's actually a principle which is called characterization tests. It's an idea that came from Michael C. Fetter from this book. I don't physically read books anymore, but I just like it. And the whole idea is that if your code base doesn't have any test whatsoever, and it's very ugly code base, you know, you're afraid to touch anything, what you can do is you just build a set of temporary tests, and those tests can be slow, can be flaky, can violate anything I just told you. But the point is they give you a temporary safety net. They might even use a production database. Really? Yes. And production is totally fine. You just let it run, and it gives this warm, fuzzy feeling that if you start refactoring the code base, you actually have something that you can rely on. That's very useful. I've done this a couple of times. And it doesn't matter that these test cases are difficult to maintain. Yes, you can even use AI tools, although that's going to be pretty hard because you need to understand the code base. But what you're literally doing is creating a test, then invoking a method or sending an HTTP request or using a library to interact with the UI. And then you observe, physically, manually, I mean, maybe in your debugger, the value that comes back from that. And that's what you put in your assertion. That's also why it's called the characterization test. It characterizes the current behavior, and you capture that in a set of tests. So then when you start refactoring, you're introducing nice seams, abstractions, moving code around, you know, introducing the actual test cases that you want to maintain. You keep the original one so that you know you didn't break anything. And that is an extremely important tool if you have to deal with legacy code bases. And by the way, this is where code coverage is becoming interesting again, because it allows you to see where you actually miss something if you build tests like these. I think there's oh yeah. Well, that's 5 minutes left. Let me see if there was anything I forgot, because there's so much I can talk about this for the full day. And no, I think I've done I covered most of it. Yeah? So, maybe to remember, there's no rule that you can follow. There are no strict guidelines that you can follow if you practice unit testing or TDD. You know, every test case, everything has unique characteristics that you need to take into account. Sometimes the unit is really small, is an individual method. Sometimes you can go broader because it's easier, but even if you go broader, sometimes it's all completely okay then to say, you know what, yes, our unit in general is bigger, but we have this particular part of the code base which is complicated. There's a lot of paths to that code base, and I create a couple of real puristic, you know, traditional unit tests for that. That's also completely okay, because you don't want to be dogmatic. There is no single solution that can be applied. It's just a bunch of heuristics and ideas that you heard on some conference from somebody who thought he was actually he knew what he was talking about, that you can apply. If not, you can always find me. I'll be around today and tomorrow, or somewhere on these channels, if you have questions or want to challenge some ideas. And that's it. We're out of time. If there's any questions, I don't know how that works. I don't think we actually can ask questions, but I'll be here around. I hope you like this talk. And I hope that you're Jesus, what could I say? I hope you're going to enjoy the rest of the conference. Thank you very much.